2-6. So yeah, if you want to get some graph paper for your homework or whatever, I have graph paper over at the side. So today we're going to talk about some families. Do you like your family?
No.
Yeah, good. Some of you have some good families, huh? Yeah, you know, I didn't really care for my family that much when I was your age. I sure like them a lot now. I'm super excited to see them this weekend. Half of them. Okay, there you go. Oh, there you go. Families of functions. Okay, I have 3 parts today. The first part, we're going to go ahead and do a little introduction onto what does it mean to be a family of functions. Guys, you ready? You ready? Yeah, you are. Okay. So first of all, let's talk about what it means to have a family in math. That's kind of weird, right? Well, basically, a family of functions is going to be the same function, just translated or shifted or reflected or anything, okay? So it's a transformation. It's a transformation of a special parent function. Special parent function. So all of these different graphs are going to come from one parent, okay? And they're all going to be in a family together. Now, if it doesn't look like that, then that's not the family that it's in. And we're going to actually do 2 of them. So here are our parents, our parent functions. The book talks about 3. We're actually just going to focus on 2 of them today, okay? We'll do the 3rd one tomorrow in its own special case. All right, so here are our 2 parent functions. F of x is equal to x, and f of x is equal to x squared. Okay, they're very different from one another. When you graph them, they look different. One's linear, one's quadratic. One's a line, one's a parabola. And so when you graph this line right here, this is the most simplest slanted line you can graph. It has a y-intercept of 0 and a slope of 1. And it's just simply the diagonal. You go, when x is 1, y is 1. When x is 2, y is 2. It's like it's copying it. And you get this diagonal right there. Okay? Now, we're going to take that line and we're going to shift it to the left or to the right or up or down, all kinds of things. So that's our first parent. And then a different parent would be the one over here. And this has a very different shape. Do you remember what the shape of a parabola is?
Yeah.
It's a U shape. So this is the very most basic parabola you can have. The vertex is at the origin, which is 0, 0. And this goes up 1 and over 1. And up 1 and over 1. But it's not going to be a V. We're going to study that tomorrow. It's a U shape. And so try to round that out as best you can and go through those points. There we go. And that's our other parent function. Okay, so those are the 2. So we're going to take those and we're going to do some stuff. All kinds of stuff. So here we go. Part B. Let's start with translations. So part B is going to be translations and part C is going to be reflections. Reflections are a lot harder. Translations are pretty basic. There's a little tricky part on translations. So we're going to have 2 different types of translations. And translations that we're going to do are going to be shifts. It's kind of like if you have a computer screen and you have an image on your screen, you click on that and you move it around with your mouse. You guys have mice anymore? Mouses? Yeah. And you don't change the shape of it, you don't change the picture at all, you just move it, right? So our shifts are going to be 2 different kinds. The first type is a vertical shift. And a vertical shift is up and down. So if I'm going to take a graph and I'm going to change it going up or down, I'm changing the y value, okay? So a vertical shift, if I take f of x and I add k to it, a constant, some number k, that is going to shift my graph up k units. Up, okay? Shifts my graph up. Takes all the y values and it adds that number to it. The x's don't change at all, but the y's all change going up. All right, same idea. If I have f of x minus k, what do you think that's going to do? It's going to shift it down, right? going to take your graph, your whole graph, and it's going to move it down. All the y values get subtracted by k. All right, so that's pretty good. People like those. Those aren't too bad. It's the horizontal shifts that are a little bit weird because it's going to be the opposite of what you think is going to happen. So our horizontal shifts, horizontal changes the x value, right? If I'm at 2 on the x and I tell you go to the left 2, you're going to go, to the left 2. It changes the x. And so when I do f of x plus h, okay, the change is not on the outside of the function. It's on the inside of the function. What that does is that's going to shift my graph to the left. And you're like, what? There's a plus there. Oh, believe me, it's true. You shift it the opposite direction. So if it's x plus 2, you're actually going to go 2 to the left. If it's minus 2, you'll shift it to the right. So if x minus h, we're going to shift to the right. Okay? It has to do with getting a 0 there. Like, for example, if I were to show you on the calculator. Clear. And let's say I graphed just x squared. Okay? There's the parabola x squared. And then I say, okay, let's do parentheses x plus 5 squared. Okay? If I do x plus 5 squared, when x is negative 5, that's when y is 0. So when I graph that, it actually shifts it 5 to the left. Negative 5 plus 5 is 0.
Oh.
I know. Yeah. If you did it the other way, like if I did x minus 5, then that would be when x is 5, y is 0. So it would shift it over there. Cool, huh? I know. We're going to do these by hand. A lot of them by hand. Okay, so let's do some. Are you ready? Here we go. Number 1. We're going to do some vertical shifts. So let's start with our parent function, y equals x. And we're going to shift this, y equals x, we're going to shift it minus 2. Okay, and you know how to graph lines. We just spent, all of last week graphing lines. So this is to graph both of them on the same graph. So let's take our parent function. I'm going to do all the parent functions in blue, and then we'll do our shift of it. Okay, so our parent function is to start by, ooh, that's gross. Start by drawing the diagonal. Okay, just the diagonal like that. And now I'm going to take this diagonal and see that minus 2 right there? That means I'm going to shift it down 2. I go 1, 2, and it still has the same slope, up 1 over 1, and they will be parallel to one another. I just took that blue line and moved it down 2. You see that? Yeah, it's pretty good, huh?
Yeah.
Okay, let's do it now with a parabola. So if I have my parent function, and then I'm going to shift this x squared plus 4. Let's see what happens to it. Y equals x squared is my parent function. I'm going to graph that in blue. Okay? When you graph your parent functions, you should have a few points on there. Like you should have a point at 1, 1 and a point at negative 1, 1. And that'll be your parent function. We're doing basic, like up 1 over 1. Okay, we're not gonna shrink it or stretch it. Yeah.
So if it's like y equals x minus 4 to the second power,
Mm-hmm.
would you have to distribute first?
No, you're not distributing at all. If it's x minus 4 inside the parentheses, that will be a shift left and right.
And then
If it's on the outside, it's up and down.
But then what if there's like a squared?
Yes, the squared just means it's a parabola.
Oh, okay.
Yeah, you don't want to distribute the squared to anything. You just want to think if it's simply x, it's a line. If it's x squared, it's a parabola. Mm-hmm. Okay, so let's take this parabola and let's shift it up 4, because that's what this means. Take y equals x squared and add 4. So 1, 2, 3, 4. I'm now going to be up 1 and over 1 from here, and it shouldn't change the shape of it at all. All it does is move it up 4. Pretty good? So far, so good?
Yeah.
Okay. Let's take number 3. Let's take y equals x squared minus 1. We're not going to graph this, but we're going to shift it up 3. Okay? This didn't start with our parent function. It started with, a different function, y equals x squared minus 1. We're going to shift it up 3. What that means is you're going to take this, you're going to add 3 to it. Okay? Shift it up 3 means to add 3 to the whole thing. Yeah?
Well, what do the 2 dots mean on the parabola on the sides when you...
Those are the other 2 points, because you don't want to draw your graph super skinny. You don't want to draw it super wide. That matters.
Okay.
So it's just your basic up 1 over 1 and up 1 over 1. You really want to have 3 points when you graph the parabola. 3 points, so that we can see the width of it.
Okay.
Yeah, so a shift up 3 is just to add 3 to it. Just add 3 to the whole thing. That's it. Okay, let's do some horizontal ones, because vertical is not too bad. You can see it's just +4 or -3, whatever on the outside. So a horizontal shift is going to happen on the inside of the function. So let's start with our parabola again, and let's have y equals x squared. And now let's do y equals x plus 7 squared. Okay. Doesn't mean you're going to get 49. You're not squaring any numbers. It means that you're taking the parabola shape, the parent function right here, which I'll graph in blue. Here's your parent function, right? You have 3 points on it, up 1 over 1, like that. There it is, your basic mother function, if you want to call it that. Yes? Yes.
Maybe.
Yeah.
Do you always start with 0?
Yeah. Yeah, the parent function always starts at 0 here.
And then it's always 1, 1?
Yep. Yeah, we're not changing the shape of it at all. It's your basic parabola, and this parabola, what's happening to it? It's getting shifted 7 to the, as Beyonce would say, yes, to the left, to the left. 7 to the left. Nobody laughed at that. I gotta retire that joke. All right, so 1, 2, 3, 4, 5, 6, 7. I'm way over here. I went into these things, and there it is. Okay, shifted 7 to the left. You okay with that? Yeah? Pretty good?
Where do you know, I don't really know how to say it, but like the points, like the U,
Uh-huh.
the points that are on the U.
Mm-hmm. They're always up 1 and over 1.
Okay.
Yeah. Unless you put a 2 out front or a 3, we're not doing that. We're just keeping it nice and simple. Let's combine one now. Let's start with our parent function, our parabola, our basic U shape, up 1 over 1, just basic U. And let's do both. Let's do a vertical and a horizontal shift on this. So we have y equals x minus 3 squared minus 4. Okay, when you look at this, look at its parent function, and then think about what's happening to the parent function. Don't start squaring things and subtracting things. Yeah?
Wait, so the square with a 7 is it like really matter?
The squared tells us that it's a parabola.
Oh.
That's what it matters, yeah. If it was like not a square, just an x, and it's a line. So for this one, we have your basic parent function, and we're going to shift this parabola 3 where? 3 to the right and 4 down. So on the inside it goes left or right, the opposite direction. On the outside number it shifts up or down in the same direction. So let's do it. Once again, see, you only have 2 parent functions. In HAM, the class I teach, Honors Advanced Math, we have 12. And the same ideas work for anything. You have a log graph, you have a sine wave that looks like that on that calculator up there, and you shift it, it still does the same thing. So for this one, I'm going to go 3 to the right, so 1, 2, 3, 1, 2, 3, 4 down. So here's what I just did was I shifted this point to there. And then I take the other points along with me, which are just up 1 and over 1, and that would be my graph. Yeah? Did you get that? Okay, so number 6. Nothing happened. Number 6. Suppose now, let's say that we have a chart of numbers, okay? And let's say that -1 is 4, 0 is 3, and 2 is 0, okay? So we have a chart of numbers. And let's say that we want to take whatever this looks like. It's just 3 points, right? We want to shift it down 4, okay? We want to make a new table of values. They're not asking you to graph it. They just want you to write a new table of values. If we're shifting down 4, what is that affecting on my graph? Which values? X or Y? The Y values, yeah. Shifting down 4 means to take f of x and subtract 4 from it. So let's take all of these f of x's and let's subtract 4 from them. So this would be, my new y value would be 0. My new y value here would be -1, and this would be -4. None of my x's changed at all. All it was it shifted everybody down 4. Okay? That's what the shift is. All right, do you feel okay with that? Oh, one more. Sorry. Number 7. I wanted to point this out to you. You know how like the parabola had parentheses? Like you have y equals x plus 3 squared is a lot different than x squared plus 3. Those are very different from one another, okay? This first one is a shift 3 to the left. The second one is a shift 3 up. Totally different shifts. I mean, you can even graph them on your calculator. I'll show you. Let's do, what was it? X plus 3 squared, and then it's x squared plus 3. And if you graph all 3 of those, there's your parent function right there. No, it's graphing them like all at the same time. That's really cool. Okay? There's 3 different graphs. They're not the same. The parent function is this one. The one that is plus 3 squared is this one, and the one that's up 3 is plus 3. Okay? So those are all very different. Now, when you do this with this right here, y equals x is your parent function, and let's say we want to do y equals x plus 3. You can think of this 2 different ways, okay? You can think of this as taking this function and shifting it up 3. The other way you can think of this is a shift of 3 to the left, right? Because it's taking x plus 3, but it should be x minus 3. So watch. When you have your basic parent function here, and then you shift 3 up, it would be here. But no, I think of this as 3 to the left. Guess what? You're still the same line. It doesn't matter on this one because there's nothing in parentheses affecting it. Okay? It's either a shift up 3 or 3 to the left, and it gives you the same exact line. So that's a little different. Okay, woo, last part. Have you had enough? Okay. Never enough.
Back to number 7. So when you said it's in parentheses, that means you go down?
No. Parentheses, so going back to this right here. When it's inside the parentheses, it's left and right. When it's on the outside of the function, it's up and down. Okay? So you got to remember that. That's why I did the one that had both of them on there to show you that one of them's left or right and the outside one's up and down. Okay, last part is reflection. This is a little tricky, so if you've tuned me out today, you might want to tune back in. We're going to have, there's a lot of different kinds of reflections, okay? We're going to focus on 2 of them. We're going to have reflections over the x-axis and reflections over the y-axis, okay? So if I take my function and I take all the x's and I do the opposite to the x's, okay? All the x's are now opposite. This is going to be a reflection over the y-axis, okay? I'll show you that. I'll show you like a visual picture of that. So let's say I have a graph. There's the graph. It's not a function, it's a person or something. I don't know what that is. And let's say that I'm going to take all of its x values and I'm going to do the opposite to them. So that's on positive 3. It's now going to be over here at -3. So now my graph is over here, right? if I take all these x's, well, what did I do? I just reflected over the y-axis, okay? It's like folding your paper and bending it, and all the points are transferring this way. That's what a negative x does. All right, the other reflection is to take negative on the outside. So the entire function gets changed. Here, only the x gets changed. Here, all of your function becomes the opposite. And that is when you reflect over the x-axis. Okay, we like to think of f of x as all the y values because that's what y is replaced with. It's replaced with f of x. And so if I'm up here, again, here's this person or whatever it is, and I'm going to change all of its y values to be the opposite, then I would be over here reflected over the x-axis. Okay? Now, there's also an easy way to remember this. If you have, we're going to just do lines. We're not going to do parabolas yet, but we're going to do the lines. If you reflect over the y-axis for this one, only your slope changes. Okay? If you reflect over the x-axis, both your slope and your y-intercept will both change. The entire function changes. So up top, only the x changes for over the y-axis, and down below, only both of them will change. Okay? So you're probably super confused, but I'm going to show you a few of them. Because this is the most confusing part of today. It really is. I'll let you get caught up. What's that? Y-intercept. Both of them change. Okay, so let's do one. Where are we at? Number 8. Number 8. Okay, so let's start with this function right here. F of x equals 3x plus 3. What we're going to do is we're going to reflect this over the y-axis. Reflect over the y-axis. We're going to draw a picture of this, and we're going to make a rule for it. Yeah?
Can you move it up a little bit? Thank you.
Okay, so here we go. If I'm going to reflect this over the y-axis, that means that I'm changing all of my x's from positive to negative, okay, or from negative to positive. So only the x gets changed. So I'm doing this, f of negative x. So it would be negative 3x plus 3. All right, I'll show you that because a lot of you guys need to see this visually, right? You're like, what's going on here? So here's my graph. My y-intercept's 3, and my slope is 3. Up 3 over 1. Here's my graph right here, okay? This right here is the y-axis. If I'm going to take my paper, which, you know, I'm writing on my iPad, but if you take your paper and you fold it on the y-axis, you guys did reflections in geometry, right? Yeah?
Shouldn't the line be a reverse into negative 3x?
Okay, I just graphed f of x. I graphed the original, this one. So now I'm going to take that graph and I'm going to do this one. So yes, it should be negative. I'm flipping everything over. So this point goes over here, this goes over here. Do you see that reflection? Do you see it? Yeah, hope so. You did reflections in geometry, you know reflections. So what happened? You're right. It's now a negative slope, but what's my y-intercept? Still 3. Okay? All it does is changes the slope. It doesn't change the y-intercept at all. Okay? All right, let's do over the x-axis now. So let's take f of x equals negative 2x plus 1. And we're going to write a rule for it, and we're going to draw a picture of it. But we're going to reflect over the x-axis. Some people like to draw a picture first so that they can see the whole thing changes. Okay? All of it's going to change. The entire f of x changes. So let's draw a picture of it first. So 1 is my y-intercept, and this has a slope of negative 2 over 1. So here's my f of x graph. This is just your basic f of x. equals negative 2x plus 1. We're going to take that graph, you're going to take your paper, and you're going to fold the x-axis. So the x-axis is here, and we're going to do a reflection over the x-axis, okay? And so your reflection is going to look like that. Well, guess what changed? Everything. Everything changed. The slope is now positive, and the y-intercept, which was here at positive 1, is now negative 1. So when you reflect over the x-axis, you do negative f of x. The whole thing changes. You do the opposite of the entire thing, which would be 2x minus 1. Okay? So that's a huge difference. Over the y-axis, only the slope changed, but over the x-axis, the entire thing becomes the opposite. And you can see that visually. Did you see it visually? Yeah, it's pretty good. Your book does a really good job too. There's this thing that if you're in the notes and you push play and it shows you like how the thing gets reflected, it's really good. If you want to check that out, be my gosh. Okay, so here we go. Last problem, number 10. It's a lot for today, huh? It's really good. Let's say that we have f of x equals x minus 7. Okay? And we don't have to graph this one. We're going to flip it over the y-axis, and we're going to flip it over the x-axis. Let's see what you get. Let's see if you understand this, okay? Reflect over the y-axis, reflect over the x-axis. They're very different, very different. So my original, or my basic function is f of x equals x minus 7. If I'm reflecting over the y-axis, then all of my x's are changing. And so that would affect this. It would be negative x minus 7. Okay, just the slope is changing. The y-intercept is not. And then over here, if I do it over the x-axis, it's negative f of x, which is negative x plus 7. Both of their slopes will change. This one will keep the y-intercept. This one will change the opposite. Okay? Yeah, it's tricky. This is higher level thinking here. A little bit.